Hi, everyone. I hope the worksheet's going well for you guys. I'm going to go through a few of them, probably maybe three. And remember, all you have to do is 1 through 5 for Wednesday. So I'll probably go over number one, and then maybe we'll do number three. So let me mark these. Let's do number one, three, and mm, let's do four. So I'll do those three for you. Um, I still want you guys to try to do this on your own before you look at the solutions. But this is remember, this is practice, and my goal is that you guys learn this stuff and you feel comfortable with it. So um, you should have the same goal, and when you approach this, don't think of it as you're getting three answers from your teacher. Think of it as you're getting three guided solutions, and you should try them before. And then throughout the video, you could play and then pause and then see if you can get the next step, right? And then play and pause. So you can just really walk yourself through this. And at the end, hopefully, you feel like you could do any of these 5 questions on your own. Okay, so the first thing in this worksheet that we are going to need to sort out is um, useless information versus useful information. So let's go ahead and let's do that. So an old pre 1987 penny is nearly pure copper. If such a penny has a mass of 3.3 grams, how many moles of copper atoms would be in one penny? Okay, so a lot of information here, but really the only thing that we need to really look at is 3.3 grams of copper, and we're trying to find moles. Okay, so 3.3 grams was what we're starting with, and then we're trying to find moles. So everything else, like this pre 1987 penny, who cares? It doesn't matter. Okay. This also is kind of confusing because it says how many moles of copper atoms, right? That's trying to confuse us. So it's just saying if you have 3.3 grams of copper, how many moles of copper would that be? So let's do that. We'll start by writing 3.3 grams of Cu over 1. Okay. On the end, we're going for moles. All right. Excuse my mouse writing. It's kind of difficult. So we need to have a conversion factor. And what I need to do, maybe I'll do it over here, is I need to figure out how many. Oh, I can't write over there. All right, I'll do it above. I need to figure out how many grams of copper are equal to 1 mole of copper. All right, so to do that, I'm going to look at my periodic table. So let's go ahead and can zoom in a little. I guess I'm gonna open it with Kami. Let's see here. Hopefully I can zoom in. All right, so here we are. I'll change the zoom a little bit closer. Copper right here, right? So 63.54. All right, so you can just take two decimal places, 63.54. Another quick note is if you have something like 0.99, you can call that 16. Okay, you can round up if it's 0.99. If it's 0.01, such as, which one is 0.01 over here? Like hydrogen 0.007, you just call it 1. Okay, we're taking two decimals, and if it's a 0.01 or a 0.99, we round. Like carbon 12.01, just call it 12. Okay, but if you have like something like lithium 6.94, you got to call it 6.94. Okay, so that's kind of the rule. If it's 0.01 or 0.99, you round. All right, so we figured out that copper was 63.54. So I can say 63.54. Okay, so I have grams on the top, so they're going to go on the bottom of the next cell. So for the next cell, I'll do 63.54 grams, and that was equal to 1 mole. So I'll put the 1 mole up top. All right, we multiply across the top, it's 30.3. Multiply across the bottom, it's 63.54. So we're going to take 3.3 because in the end, you divide whatever you have on the top by the bottom. Right? So remember, we multiply, divide the top by the bottom. So 3.3, which is 3.3 times 1, divided by what 1 times 63.54, which would be 63.54. Our answer would be 0.05. 0.05. So that is the answer for the first question. 0.05 moles of carbon are in 3.3 grams. Next one. A raindrop has a mass of 0.050 grams. How many moles of water does the raindrop contain? Okay, so now we are given grams and we're trying to convert to moles, and it's water, so it's H2O. All right, so let's start by writing in what we're given. 0.05 grams of H2O. Put it over 1. That's a crazy looking G, but I'm doing the best I can. All right, so now I need my conversion factor, right? I need to figure out how many grams are equal to 1 mole H2O. You can read that. How many grams of H2O equal to 1 mole? So we go back to our periodic table. So H2O, 2 hydrogens. Hydrogen both have a mass of 1. So 1 plus 1 equals 2. I'm going to add that to 1 oxygen, right? Because it's H2O. So 2 hydrogens, 1 oxygen. 1 oxygen is 16. So I got to add that to 16. I get 18. So 18 grams are in 1 mole of H2O. Okay, 1 mole of H2O is equal to 18 grams. So over here, I put 18 grams. All right, so since I have grams up top, I'm going to put grams down bottom. So I have 18 grams H2O, and that's going to be equal to 1 mole of H2O, right? We write the one part of the conversion factor on the bottom, the other part on the top. Since grams is on the top and bottom here, it's going to be canceled and be left with moles. So I'd multiply across the top and I'd get 0.05. I multiply across the bottom, I get 18. So then I take 0.05 divided by 18, and I get 0.002. 0.002, and this would be moles. So what does that mean? Well, it means if I have a really, really small mass of water, well, I'm not going to have a lot of moles, right? It's going to be a pretty small amount of moles as well, right? Since in 1 mole, I have 18 grams. If I have way less than that, 0.05 grams, yeah, of course, I'm not going to have a mole. I'm going to have way less than a mole. Okay, next one. This one's a little harder because it's swapping the order of things, and it's going to test if you know what you're doing. So this says, what mass of water, so I'm looking for grams here, would you need to have 15 moles of H2O? So it's kind of worded in a way where you think 15 moles of H2O is what you're ending at, but it's not. That's what's given to you. That's the starting amount. So I have 15 moles H2O over 1. Okay, I'm looking for grams of H2O in the end. That's what I'm trying to get to. Okay, so I have to do the same thing as I did up here, but one small change. Now I have moles of H2O on the top and not grams. So because of that, on this cell, I'm basically going to be flipping this because I want to cancel moles. So I'm not going to write 18 grams down below for my conversion factor that we established up here. Instead, I'm going to write the other part of the conversion factor, which was the 1 mole. And the reason why I'm going to do that is I want to cancel moles of H2O. So 1 mole of H2O on the bottom, okay? And then I'll put the 18 grams H2O up top. And when you do that, you'll see that now I have moles of H2O on the top and bottom, so I can cancel it, and I'm left in grams of H2O, which is what I want to be in. Okay, so in this one, 1 times 1 on the bottom is just 1. So then the top will be my answer here. So 15 times 18. So let's do that. 15 times 18. I'm going to get 270. So 270 is my answer. 270 grams of H2O. Does that make sense? Well, I start with 15 moles of H2O. Each mole has a mass of 18 grams. Yeah, it would be a lot of grams there. So again, the process, you figure out what number you're given, you figure out what unit you need to convert it to. It's either they're going to be moles or grams in this case. Start with what you're given over 1. Okay. Whatever you have for a unit in the first cell is going to be on the bottom of the next one, because we want to cancel our units by putting them on the top and bottom. Because if something is divided by itself, it goes away. Okay. And then we multiply across the top, the bottom, divide the top by the bottom. Okay, guys, I hope this was helpful. Make sure you send me an email if you have any questions at all, and I can send you individualized, little videos like this to help get you through. All right, happy Tuesday.